So hello everyone and welcome to a new video on job design. So last video we talked about job design, the theory behind it, how to make a workplace better for performing the job. We talked about the methods, the job design. And now we're going to talk about time studies. So time study is basically we want to measure the time it takes to perform a certain task. So we have to study tasks. So we could divide the job as we've seen in previous videos into tasks, and then we could time those tasks. And the idea is to get a standard time. And it's basically the time a qualified worker is going to take to complete this task. And this standard time is going to be very important because it's a time to measure against. But in order for us to get there, there is few steps that we need to do. So first of all, we want to do time studies, stopwatch time studies. So we want to time tasks workers do, and then maybe we um, we contrast this against some predetermined time standards, or we're creating the time standards. So here are the steps. So we're going to define the task to be studied. That's the first thing. Then we are going to calculate n, which is the number of cycles to observe. How many observations do we need to take? How many times do we need to do time studies? How many times we're going to pick individuals and time them on the tasks? Then we're going to find the time or job rate performance. So we're going to have a performance rating for the worker, and then we compute the standard time. So now we're going to be focusing on n, how to find n. It's the number of cycles to observe. So the number of cycles to observed is going to be defined by these two equations. And again, we have a preset desired accuracy. So before doing the test, the time studies, we decide on a form of an accuracy. So maybe we decide on 98% accuracy or 99% accuracy, and whatever our accuracy is going to affect how big our sample size. So we have two equations. The first one to your left is going to be used in preliminary studies. So that's the first thing you want to do. Your first study, your first stopwatch time study. So a smaller sample is needed, and then towards the end of the study, we want to redo this time stop study now with an n is not much bigger based on a bigger, larger sample size. So now let's see what's packed inside these equations. So I mean, to the left, we said this is probably an initial study. This is maybe a secondary study. So if we have a case of two studies happening, the first one might be to the left, the second one would be probably dictated by the one to the right. So first of all, Z, we're all familiar with Z, which is the number of standard deviation, and it's usually corresponding to some confidence interval. So usually we have a confidence interval, and based on that confidence interval, we develop a Z, and we could do that from the normal distribution curve. Then there's S, which is the sample standard deviation. A is the desired accuracy, and this is something you decide. The person doing the time study will decide on how accurate he or she wants the study to be. X bar is the sample mean. And then for the equation on the right, we need to get the maximum acceptable error you will allow, which is E, and obviously is the number of observations what we're looking for. So let's look at this question. Give you a few seconds. You could always pause the video if you want to read the question. Looking to determine the number of observations. So a consultant is looking for so he's looking for n basically, or she's looking for n. Data shows an average time, that's our x bar. Standard deviation, that's our sigma. The consultant would like to have a z, that's our z. Desired accuracy proportion. How many? Again, we're asking for obviously n. So n is what not known in this question. So since they're telling us this is an initial time study, so we know that we're going to be using the equation to the left. Now we know what x bar is, standard deviation, and z. So all we have to do is just plug in the numbers. They're giving us a, so we know n is equal to zs over ax bar squared. Okay, and you just plug in the numbers, and you know what z is 3, s the standard deviation 1.6. Now notice here the standard deviation is not written as in terms of sigma, it's in terms of s, because this is a sample standard deviation, 0.04 times x bar, which we know what x bar is, 4.5. So if we multiply all these numbers out, we should get 711.11. Now when we are determining how many observations we should make, then we need to round up, because we can't have 711.11, so we do round up to 712. It has to be a whole number. So we always round up on these questions. So now let's look at this question, and I'll give you a few seconds to read the question. So consultant determined to look for the number of observations, so we need n, so they're asking for n. X bar is 6, standard deviation is 3.2, confidence interval of 95%. Okay, so now, first of all, then, which equation to choose? Obviously, we're going to choose the equation to the right, because they're saying this is a final time study. So we choose the equation to the right. Now we have a confidence interval, so we don't have a z, but we have a confidence interval, and we could get a z from the confidence interval. So if we draw our normal distribution curve, since it's 95% confidence interval, then we know that there is going to be 5% left on the curve, and this is confidence interval is two-tail. So we have 2.5 here and 2.5 here. On each side we have 2.5. So we're looking, so if you have the z-table that is shaded from midpoint, you're going to be looking for the probability of 0.475, and you're looking for that corresponding z. And that corresponding z should be 1.96. So z for this, for 95% interval is 1.96. So we know z, we know all the different items we need to figure out n. So now we just need to plug in the numbers. So 1.96 times 3.2 divided by the e, which is 0.4. Now there's a lot of extra information put in this question that is not needed. We don't need what x bar is. Okay, I think that's the only information that we do not need, the x bar. It might have tricked you into thinking that you need to use the equation to the left, but remember, this is a final time study. So our answer is 245.86, and we have to round it up to 246. So the consultant needs to do 246 observations. So stopwatch time study. We are aiming to get the standard time. So we just talked about n, how to get n. But I mean, this is not the goal. The goal is to get the standard time, but n is going to get us there. N is going to help us calculate what's so-called an observed time. An observed time is going to be the sum of recorded times divided by the number of observations. So we need to know the number of observation. We calculate n. We could get an observed time. Then we get something called a normal time. And this is to take into account that sometimes some of the workers who are in these time studies, they're probably nervous, so they're working 10% faster than the usual. Time studies don't reflect the reality, because when somebody knows their time, they're gonna behave differently than normal circumstances. So this is the performance rating is going to take care of that. So we multiply the observed time by some performance rating. And then we get the very important standard time. And this is a very important calculation because standard time tells us what is the goal for doing this task, what is the benchmark for doing this task, and it's going to be the normal time times some allowance factor. And the allowance factor is going to allow for breaks and other things and so on. So basically the standard time will allow for some allowance factor. So what is this allowance factor? Well, I mean, the standard time assumes is the time that it should take to perform a task if there are no delays, no rest breaks, but in reality, there's going to be breaks. So this factor is going to allow for such things and incorporate it into the standard time or take it out of the inflated time so we could get the real standard time. So allowance can be used. So allowance, in questions, we could get a task time allowance or a workday allowance. So depending on the question, we could get either a task time allowance or a workday allowance. So as we said, the standard time is equal to normal time times the allowance factor. Now, if we get an allowance factor that is geared toward the task itself, then we take the normal time and we multiply it by 1 plus the allowance. Now, if it's the allowance is for a work day, and that's the majority of the time we're going to get an allowance like this for a work day, then we're going to take the normal time and divide it by 1 minus the allowance factor. Okay, so the majority of the question we're going to see a workday allowance factor. Now, this slide gives us another insight into why the difference between allowance task time and allowance workday. So if we have different tasks, each one having different time, and each one having different allowances, then we would want to use the task time. If our tasks have similar allowances, then we would use the workday allowance. Again, in the question, most question you will see, they will give you the instant, is it a task time allowance or a workday allowance? So I'll give you a few seconds to read these questions. So we have a bank manager that has basically calculated or figured out what the observed time is. So we know what the observed time is. In this case, it's 0.4 hours. And we know that the trainee works 6% slower than normal. Allowance workday, this is very important. So we're getting a workday allowance. So we're gonna divide by that allowance rather than multiply. So we're gonna divide by 1 minus the allowance. So we're gonna get the normal time. So for the standard time, we're gonna get normal time divided by 1 minus the allowance because it's a workday allowance. So we know the observed time. We know that the worker is working 6% slower. And we know that the allowance is 30%. So the performance rating, because the worker works 6%, works out to be 0.94. So we go 100 minus 6, to give us 94%, but we need the rating to be a ratio, so we divide it by 100, so 0.94. So right away we could calculate the normal time because we have the observed time and we have the performance rating, so we're gonna get 0.38 hours. Now the standard time is going to be taking the normal time and dividing by 1 minus the allowance, which we have 30%. Again, we have to turn the percentages into ratios. So 0.38 hours, 1 minus divided by 1 minus 0.3 is going to give us 0.54 hours, and that's our standard time.